This is the second video in our series, Exploring Cimatron for Mold Design. Please review the first video if you haven't done so, as this is a continuation from where the first one left off. In this presentation, we will focus on dividing the part into cavity and core surfaces using quick split, and then considering part changes or engineering changes by means of compare. And thank you very much for considering Cimatron for mold design. In our first video, we left off with the tool Direction Analysis, which helps us to find the primary pull directions and any trapped or undercut conditions. Clearly, we can see the value of this in determining the part's mold position or if it needs to be tipped. So now we will use quick split to divide the part up into cavity and core surfaces. Here we will select our first pull direction. We will give it the appropriate name, and then we will pick a face that we know lies within that pull direction. By default, it selects the active Z-positive direction for the pull direction, but we could pick another if we needed it. Now all the faces that it sees in that direction are placed on the cavity. Here's our first glimpse at the slide bar, which dynamically will separate all the pull directions we create. And please notice the nice clean separation that it makes along parting line. Let's now create the core split. We will pick the appropriate name, in this case core, and then we'll tell the system to pick only those faces which have not yet been assigned. Then we pick a single surface that we know faces that pull direction. Now we make sure that our direction vector is pointing in the Z negative direction or the core pull direction. So now the core surfaces are identified, and we see in yellow anything that is at least partially undercut or trapped between the two pull directions. We will accept the core faces now. The yellow faces will remain unassigned since they're trapped. And again, using our dynamic sliding bar, we can see, by separating cavity and core, which faces have yet to be assigned. The ability is there to place these remaining unassigned faces on a separate pull direction if we so desire. In this case, we're simply going to attach them manually to the core faces and let the lifters take care of them. And that is done by simply middle mouse clicking over the core faces. Another nice feature is to display the entire part while the different split directions are separated. Another important option to quick split is the ability to analyze faces based upon their draft angle. These draft angles are displayed based upon a range of angles and colors that we can fully customize. Individual features of interest can be tagged so that that draft angle value at that location can be seen on screen, and this all the while the part is in its dynamic separation. In this case, vertical walls have been color coded as violet, whereas anything that's seen undercut or trapped is displayed in red. And finally, this information can be output in a PDF file so that it can be shared with other engineers or with the customer. Engineering changes are a real part of a mold designer's life. So let's look now at comparing a current design to a new revised level. After we select the new revised version, it will be brought in and overlaid on top of the existing model. A comparison chart now shows features which are changed in the new model, shown in blue, versus the old model, shown in red. Everything that remains the same is displayed in gray. Very easily, we can click on and off the different display sets to display the entire new model or old model. So very quickly then, we can see all the changes that have occurred in the design. Not just those changes in the very center front of the part, but also out on each of the far ends. In addition to comparing the old and the new model to see what's changed, we can also run a deviation map, which will show us just how much material has been removed or how much it may have been increased. The display to this deviation map can be set to a range of sizes and colors of our choosing. So first, let's set the display to show only those areas where material has been removed. Here we can see clearly how material has been removed from those flat areas. Let's set the display now to show the areas where material has been added. And of course, both added and removed areas can be shown together. As is the case with the other analysis tools, all this information can be published to a PDF file where again it can be shared with other engineers or discussed over with the customer. So now after running the comparison, we have faces that are not assigned to either the cavity or the core side. So to remedy this, we will first stitch these new faces into the existing model. From here then, it's just a matter of rerunning the quick split directions. To do that, we'll right-click on the split direction, in this case the cavity side, and say Edit Direction. We want to keep the same pull direction that we used before, in this case Z positive, but we'll have the system now look back through all these faces again and then recalculate what it sees in that pull direction. And then of course we will do the exact same thing with the core direction. Some of these new faces, like the faces from before, may be trapped or undercut, so we'll just simply manually assign them to the cavity or the core side. To do that, we'll select the faces and then middle mouse drop them on the pull direction we wish to assign them to. And with that, we've incorporated the engineering change into our design. These exact steps can be done at any time during the mold design process, even after the full cavity and core block separation. Thank you for reviewing this presentation and for your interest in Cimatron. Our next video will deal with the subject of creating parting lines, parting and shut-off surfaces, and separating cavity and core blocks using active parting.